Hello. Hello and welcome to this video. In this video, we will solve set number 28, that is question number 271 to 280. The link to download the PDF will be given at the end. So let's see where you can download the book. We can go to astrologer.org, click on the second link and get the PDF. So as you can notice, if you look at the date, this is 14th December 2025. I've just updated it by fixing the mistakes in the previous video. You can download from here. The link will be given at the end, will be given in the description of the video. And as always, I will say that when I'm stating the problem, you should pause the video. And only if you cannot solve the problem, you should watch the solution. So let's get it into full screen. Okay. Now, let's get started. So question 271 says that find the values of m for which the equation 5x square minus 4x plus 2 plus m into 4x square minus 2x minus 1 is equal to 0 has equal roots. The product of roots is 2 and the sum of roots is 6. So there are three questions. So first we rewrite the equation as 5 plus 4m into x square minus 4 plus 2m into x plus 2 minus m is equal to 0. For the roots to be equal, the discriminant has to be 0. So the discriminant is 4 into 2 plus m whole square minus 4 into 5 plus 4m into 2 minus m, which eventually becomes 5m square minus m minus 6 is equal to 0. And it gives us m is equal to 1 and minus 6 by 5 as the root. The product of the roots of this equation is 2 minus m by 5 plus 4m, which is given as 2. So if you solve this, it becomes 2 minus m is equal to 10 plus 8m. Okay, 10 plus 8m. Now this implies that m is equal to minus 8 by m. There should be m is equal to. Sum of roots of this equation is 4 plus 2m by 5 plus 4m, which is given as 6. Implies that m is equal to minus 13 by 11. Question 272 says that find the relation between the coefficients of the quadratic equation, this should be equation, x square plus bx plus c if one root is n times the another. So we let one root to be alpha, then second root will become n alpha. Sum of roots is n plus 1 into alpha is equal to minus b by a, so alpha is equal to minus b by n plus 1 a. Now product of roots would be c by a. So we plug in the value of alpha from here, we get nb square by n plus 1 whole square a square is equal to c by a. So we get n plus 1 whole square ca is equal to nb square. So that is the relation between the coefficient of the quadratic equation. Question 273 says that if the roots of the equation x square plus bx plus c are in the ratio 3:4, prove that 12b square is equal to 49ac. So the ratio is 3:4. In the previous question, the ratio was 1:n. So once we have that, we put this value of n in this equation. We get 3 by 4 plus 1 whole square, ca is equal to 3 by 4 b square. And you simplify this, you get 12b square is equal to 49ac. Question 274 says that if the roots of the equation 4x square plus ax plus 3 is equal to 0 are in the ratio 1:2, show that the roots of the equation ax square plus 3x plus a is equal to 2 are imaginary. So from this problem, we can say that a is equal to 4, b is equal to a, c is equal to 3, and n is equal to 1 by 2. Now we substitute this into this equation, we get a square is equal to 54. Now discriminant of this equation is 9 minus 4 into a square minus 2a less than 0. Thus, roots are imaginary. Now, question 275 says that if one root of the equation x square minus px plus q is equal to 0 be m times their difference, prove that p square into m square minus 1 is equal to 4m square q. So we let alpha beta be the root, then alpha plus beta is equal to p, and product of roots is alpha beta is equal to q. Now it is given that one root is m times their difference. So one root is m times the difference. So in this case, this is wrong. So in this case, alpha would be m into alpha minus beta. So this, I will fix this to 75 and we will continue this in next video. Question 276 says that if the difference of the roots x square minus px plus q is equal to 0 is unity, prove that p square minus 4q is equal to 1 and p square plus 4q is equal to 1 plus 2q whole square. So we let alpha beta be the root, then sum of the roots would be p and product of roots would be q. And given that difference of the roots is 1, so alpha minus beta is equal to 1. So we square this, it becomes alpha plus beta whole square minus 4 alpha beta is equal to 1. That is p square minus 4q is equal to 1. Also, alpha minus beta whole square plus 2 alpha beta whole square, that is alpha square plus beta square whole square is 1 plus 2q whole square. Now from this equation, alpha square plus beta square whole square is equal to alpha to the power 4 plus beta to the power 4 plus 2 alpha square beta square is equal to alpha to the power 4 beta to the power 4 minus 2 alpha square beta square plus 4 alpha square beta square. So we can write this as alpha square minus beta square whole square plus 4q square. And this gives us alpha plus beta whole square into alpha minus beta whole square plus 4q square is equal to p square plus 4q square. Question 277 says that find the condition that the equation a by x minus a plus b by x minus b is equal to m may have roots equal in magnitude but opposite in sign. So we simplify the equation, we get mx square minus xm into a plus b minus mab minus ax plus ab minus bx plus ab is equal to 0. That is mx square minus x into m plus 1 into a plus b minus ab into m minus 2 is equal to 0. The roots are equal in magnitude but opposite in sign, that means sum would be 0. So sum of roots is m plus 1 by a plus b is equal to 0. That implies either m is equal to minus 1 or a plus b is equal to 0. Question 278 says that find the relation between coefficient of the equation, there is a typing mistake, equation ax square plus bx plus c is equal to 0 if one root exceeds other by k. So we have alpha plus beta is equal to minus b by a, alpha beta is equal to c by a, and the difference of roots is given as k, alpha minus beta is equal to k. So we expand this, we get alpha plus beta whole square minus 4 alpha beta, and that is equal to k square, that is b square by a square minus 4c by a is equal to k square, and thus we have b square minus 4ac is equal to k square a square. Question 279 says that if one root of the equation ax square plus bx plus c is equal to 0, b square of the other, show that b cube plus a square c plus ac square is equal to 3abc. So if alpha is one of the roots, then alpha square will be the second root. So sum of roots would be minus b by a, and product of roots would be alpha cube, that is c by a. So sum of the roots which we have, we cube it. Okay. So upon cubing, we get b cube by a cube is equal to minus alpha cube into alpha plus 1 whole cube, which is equal to minus c by a. Okay, this is minus alpha cube, and alpha cube is c by a, so minus c by a, and alpha plus 1 whole cube can be written as alpha cube plus 3 alpha into alpha plus 1 plus 1. Now this we substitute from here, and we get minus c by a, and c by a here for alpha cube minus 3b by a, because alpha plus alpha square is nothing but alpha into alpha plus 1. So this becomes minus 3 by a and plus 1. So you simplify this and you get the desired condition for this. Question 280 says that determine the value of p for which one root of the equation x square plus px plus 1 is equal to 0 is the square of the other. So if one root is alpha, then the other root will be alpha square. So alpha plus alpha square is equal to minus p and alpha cube is equal to q. We proceed like this equation, the previous equation. Sorry, I'm reading the wrong question. 281 is this. So alpha plus alpha square would be minus p and alpha cube would be 1. Okay, this equation. Okay. And this equation is again wrong. This is not x square plus bx plus c. This is x square plus px plus 1. Okay. So alpha plus alpha square is equal to minus p and product of roots would be alpha cube is equal to 1. If alpha is a cube root of unity, because we have alpha cube is equal to 1, then alpha is equal to minus 1. That is one condition. And if alpha is minus 1, then p is equal to minus 2, because you put this. If alpha is minus 1, alpha would be 1. This is not minus 1, this is plus 1. Okay. If alpha is plus 1, then p is equal to 2 minus 2 from this equation. Else, if it is one of the complex numbers, then we know that 1 plus omega square is equal to 0, where omega is cube root of unity, which will make this p 1. So with this, we come to the end of this set of problems. There are lots of typing mistakes. For example, this equation 275 is completely wrong, and then that equal. Where was that? 271. Yeah, this one, 272. So there were lots of typing mistakes. I apologize for that. And I hope that you are finding this series of videos useful for your studies and exams. Also, I hope that you are able to practice these questions on your own without looking at the solution. If you have problems, let me know in the comment box and I will try to suggest techniques which can help you. All these questions were very easy. After 210, the problems have been very easy. Before that, they were quite difficult. So if you are not subscribed to the channel, make sure that you subscribe, and you would like to press the bell icon so that you can get notification of the videos. Do not forget to like the video and share it on social media so that your friends and others can reach the video and get benefit from this. The link of PDF will be given in the description. So once again, thanks a lot for watching the video. Enjoy.